Hello, this is Alistair Plotnick with Physics 2212, and this is the Charge Tapes Lab. So first, the introduction. The purpose of this lab is to determine approximately how much excess charge is on one piece of clear charge tape. The basic models used here are Coulomb's law, the electric field equation, the electric force on a charged object, and the equation for a gravitational force. So a quick preview of our results. The excess charge calculated on one piece of clear charge tape is 1.35 times 10 to the negative 8th coulombs. So systems versus surroundings. Our system here is the two pieces of U-tape shown to the right. Our surroundings are the earth and the air. The electric and gravitational forces are the only ones being considered. So the details of the experiment. First, I put the base tape at length 0.2 meters onto the desk. I created an equal size U-tape and left handle and stuck it on onto the base tape, and then I ripped the U-tape off and put it aside, and I did this twice. And then the U-tapes were repelled from each other, meaning that they had the same charge. The tapes were attracted to the negatively charged pen, meaning that they are positively charged. I attached one of the U-tapes to the notebooks over a table in order to keep it still, and then the second U-tape was held up for the first one until it began to float, and a distance of 0.029 meters recorded in the movement of the first tape. So our assumptions here is each U-tape has the same net charge. Each tape is represented as a point charge with all charge located in the single point in the center of the tape. We do not ignore air resistance, and we do not assume the charge is evenly spread throughout the tape. So our initial tape data is 0.2 meters, and the mass of the tape is 2 times 10 to the negative 4th kilograms, and the distance between the tapes when they began to float was 2.9 centimeters. So our calculations here is first the gravitational force, which is the mass times the gravity, and then here we were able to set that absolute value of it equal to the electric force, because that was the only other force being considered, and then from there you put it equal to Coulomb's law, and then from there, since the tapes have the same charge, you're able to make that Q squared and then rearrange the variables and get the square root. It's for Q to be 1.35 10 to the negative 8th coulombs. And the number of deficient electrons is the charge itself divided by the value of an electron in coulombs. And here you got 8.4375 times 10 to the 10th electrons. So more calculations, the fraction of atoms that gave up electrons. So here you have the total number of atoms being the distances divided by 1 to the 10 to the negative 10th squared, and here you got 5 e to the 17 atoms, and the ratio of deficient electrons to atoms here is 1.68 times 10 to the negative 7th. So here are my details of my coding, which are linked in the description. First, I set my initial variables up, and then from there I calculated the gravitational force, and then set the electric force equal to its absolute value. Made my particle and observation location vectors, and then from there rearranged the variables to find Q, and then get also my ratios for deficient electrons and atoms to deficient electrons as well. So here was the output of the code, which looked like this model and gave us these outputs, which were very similar to our actual results as well, which is good. So what if the electrons had a positive charge and the protons had a negative charge? What would change about the observations you made with your tapes and with other charged objects? So the tapes would still have the same charge, meaning they would still repel to each other and float. So nothing much would really change there. And then why is it important to handle the charged tapes as little as possible? What happens when your charged tapes come into contact with your hands or other objects? So they are electron deficient, which means they're positively charged, and interaction with your body / other objects could transfer electrons, removing the charge from the tapes. Possible source of error was excessive contact with the U-tapes, and another possible source of error in the lab was my setup with the notebooks and inaccurate measuring, just because we're human, not everything can be perfect. And then if the pieces of tapes were held parallel. So conclusions here is my computational model was able to accurately predict the magnitude of the charge of one piece of tape, and with the absence of other forces, the electric force equals the gravitational force in this scenario. So yeah, that's all I have for the charged tapes lab. Thank you.